All right, so I will be brief because I'm not going to be doing the interviewing today. We are fortunate to have our CEO, Michael Malyuk, taking the reins to interview a pair of applied research scientists working at ServiceNow who have an exciting new library featuring a fictitious character that we'll get into later. But before I do that, just a couple of quick housekeeping items, and then Michael, you can take over. And then either Frédéric or Parmida, whoever wants to present after I stop presenting, you can kind of take the reins there. So first of all, if there are questions that come up over the course of this interview, please join our Label Studio Slack community to ask those. You can ask those questions over in our hashtag webinars channel. As normal with these webinars, we answer or try to answer questions that are asked over there. Also, this is not really an announcement. Sorry, I could be announcing there. But yeah, if you haven't already subscribed to our monthly newsletter, you can subscribe to it there. Once monthly, you get all the latest happenings from that month, all the content releases, blogs, videos, etc., all in one neat, simple email. And then this is relevant to the topic at hand, a new article on using Bayesian active learning, authored by one of our two interviewees today, Frédéric Branchot-Charon. I really wanted to try to say that. I hope I didn't butcher it. So for those who want to deep dive on the topic at hand, feel free to go to this URL, or in our Slack channel, it's over in announcements, or I'm sure there'll be various shout outs throughout this interview. So with all of that said, I'm going to stop sharing, and Michael, if you wouldn't mind taking over.
Sure. Thanks for the introduction. All right, we're going live. I think I'll let Frédéric and Parmida share their screens. Okay, so I think first I heard about BaaL and active learning when I was looking at the work that you've been doing, I guess both of you at Element AI, and we've been following that very closely and kind of had our own developments in terms of what active learning can bring to the table in terms of the data labeling, in terms of the model interaction and improvement. And I'm super excited to have you both on the webinar today, just to present what you've been working so far. And I think it would be very interesting to learn about the name for the library as well. So I'll let you take it from here, and I'll have a lot of questions throughout the presentation, because active learning is something that I think we are usually hearing a lot from the market. So a lot of our customers, a lot of Label Studio users, they're all very interested in active learning approaches and how that can improve their model pipelines. So let's get started.
Yeah, thank you for having us today. We're really excited to show our library to, well, everyone watching. So something that I think we want to make clear is that, like, as you said, the industry, they want active learning, they talk about it, and in their mind, in the mind of many people actually, active learning is a way to save money by cutting, like, you need less labor if you label less data, you save money, your model is better. Like, there's only pros to using active learning. And in our case, we come from a different background, which is the interaction between the model and the human. We think this is very important. Like, we often talk about automating jobs with AI and stuff, but in some cases, we don't want that. Like in medical imaging, for example, like you wouldn't want an AI to say, oh, this person has a tumor or something. Like, we need a human to validate that. And so this is where, like, there's a cool loop, and hence the name human in the loop, where the human will validate the model's prediction and they can help each other. So again, if you go back to medical imaging, if a radiologist does 300 scans per day instead of 100 without an AI, it's much like everyone wins, right? So if we keep a human in the loop, they can ask for transparency. Like the human, they don't trust the model blindly. We saw that multiple times. So they can say, okay, why did you do that? Why did you tell this prediction? And hence, like, the human can validate, oh, on this prediction, you were biased against this. And if we make this decision, it's going to be unfair to some people. So we think, like, there's a very strong relationship between like a human and an AI. And this is where, like, active learning comes in. It's a good example of that.
I think what's interesting that what you're talking about is that active learning, kind of the general understanding around active learning is that it can save you on the annotation budget, but it can go way further than that. It can actually bring what do you call it, fairness into the AI models and reduce the bias, which I think is kind of like this a little bit of a shift from the traditional thinking around the active learning.
Yeah, and it's a very, like, active learning is a dynamic field. Like we just published a paper on that like 3 months ago on how active learning can help in fairness, for example. Right. So I just want to finish on how active learning fits in the human in the loop, and also a small touch that active learning brings to the table. So like when you don't use active learning, you have like a sequential experience. Like you have a bunch of unlabeled data. You get your labeling team and say, label this data. And then they label the data. They send it back to you or your data science team. They will train a model, and then that's the model. And that's the end of the story. Whereas when you use active learning, there's like a conversation that happens between the scientists and the labeling team. Because the labeling team, they don't want to label for nothing. They only want to label what will be useful to the model. And the data scientist, he knows how to code the model. So there's like a loop and like dynamic experience where the labeling team will label some images or whatever you're labeling. And then the model will be trained on those. And then it will be able to ask for, oh, I'm not sure of my decision on these unlabeled example. Could you help me on that? And again, we go back to human in the loop and HAI at large.
It's interesting. So when you say that only label what is useful to the model, I guess that's kind of like where your library comes in, kicks in. But this notion and understanding of usefulness, it can be so diverse, right? Because, for example, if you kind of want to minimize the annotation budget, you have one understanding for usefulness. When you are doing when you're trying to improve and make the model more fair, the usefulness measure can be very different, right?
Right.
I'm kind of curious to learn if like how to think about how to define the usefulness and connect that to the active learning.
Yeah, so that's a very good question. And I think this is where, like, including the AI scientists in the loop, this is like where you get this kind of information. Like, do you need to label up until a budget, or do you just want to get the best model? If for the scientist or for your use case, it's very important that fairness is at the core of the model that you're building, then we should not stop until the model is fair. So by keeping labeling the most informative examples, at some point, the active learning will plateau somewhere and you'll say, okay, this is how fair my model is. And directly when labeling, you get a feel of, oh, my model will have trouble in production. Maybe we should not do this task anymore with a model. We should just use a human. So you get a lot of information from that.
Yeah, and what is very interesting here is that this understanding of usefulness changes over time, right?
Yes.
Because, for example, if you're just starting, you kind of want to get the model deployed as quickly as possible. So you want to minimize the budgets that you invest into the labeling, right? But over time, when your model is in production, you can start thinking about, okay, we want to make it more fair. So it's kind of like it transitions from one understanding into another one, depending on where you are in your model pipe, like development stage, basically.
Yeah, exactly.
Interesting.
So I'll now give the end at Parmida to say, yes, we can create more balanced data, but there's many other things that we can do with active learning.
So I'm going to take over here. The main question right now is why we want to use active learning. I think, like, in our opinion, there's a lot of potentials for active learning. Active learning, as Fred mentioned, is a very dynamic field, and there are many more things that we haven't still like discovered about side effects of active learning that could be beneficial in different fields or situations. However, if you want to just like name some, of course, you'll have same performance with less labeling data. And you'll, as Fred mentioned, create an interactive experience for the labeling team. They'll have a better sense about the model and how model works. And over time, they can better understand that, okay, so if I label like this, the model reacts this way. So maybe I should, for example, in NLP case, maybe I should like label this way or use these words. And of course, like active learning creates more balanced data set, which is also a side effect.
Can you maybe, I'm just curious about if you can maybe speak a little bit about the balanced data set and how that works, because maybe the audience that we have today, they're not aware about what can happen if you have unbalanced data set and what the balanced data set even means.
Yeah, so actually we have exactly, we have some examples in the next slides. And it's also these notations and the graphs have been represented in our papers that we've published. So let's say that in reality, a lot of data sets that you have in production, they don't have like the same number of samples for different classes. So you have like underrepresented classes, you have overrepresented classes, and of course, if you just use a machine learning algorithm with just random sampling, you'll just oversample the overrepresented classes, and you kind of like don't learn or learn less about the underrepresented classes. However, when you use the notion of uncertainty, you kind of like bring to the attention of the model, like what samples are more on the model is more uncertain about. And let's bring that more for the model. So the model picks what I haven't learned yet, and I need to learn about these things. And that actually creates more balanced data set. So what happens in basically in the result is that the model kind of like limits the amount of sample that it gets from the overrepresented classes, and then try to get more samples from the underrepresented classes. So it kind of like creates a balanced data set at the end. And here in the graphs, we can see an example of a data set that we actually had Fred created, I think, in this data set before my TCD. And so this data set has highly underrepresented classes. That here we have, for example, the truck or bicycle, and you can see the differences between like just random sampling versus if you use uncertainty estimation methods like BaaL or entropy, how you can get better accuracy and the difference between accuracy for all of these classes.
And I think just one thought that I have along the way is that what seems to be important, especially for the initial active learning phases, is that the labeling that happens should be as accurate as possible. Otherwise, if your annotators are making mistakes, that would mean that your model is learning based on the mistakes, and your active learning may not generalize over the data set correctly. So I think this is something that is also, we have seen that in a number of use cases where, because of the initial phases of labeling, the annotators were making a lot of mistakes, then the model is not going where it's supposed to be going, and you start labeling the items that are not really the ones that you want to be labeling.
Yeah, exactly. So actually, to answer what you just mentioned, is actually a very important subject. However, it's also interesting that we did one experiment. I believe it needs a lot more experiments in that regard, but we did one experiment in the paper that we published for the package itself, that if you have like a small amount of noise in the labels, actually, surprisingly, active learning can just like oversee that noise. And you still can have good performance. However, of course, like it needs to be like under a certain amount. And I mean, it needs a lot more experiments to kind of figure out what are the parameters, exact parameters, but that was something that we figured out.
Yeah, that's interesting and kind of unexpected, I guess.
Yeah, can I add something on that?
Sure.
So something that is interesting with the labeling noise is that, and that we published in our NERIS paper last year, is that when you use regular active learning, you're highly impacted by labeling noise. But when you use Bayesian active learning, so what we do, it's much more robust to the labeling noise because we use Bayesian deep learning.
Interesting. Yeah, I think it would be great to kind of talk a little bit about that further in the presentation. Yeah.
Yeah. So then again, like this is another example that after we understood like what is the effect of active learning in creating more balanced data sets, we kind of started to think about this question that, okay, a lot of biases that happen in the data sets are actually as a result of like overrepresentation of a certain subgroup that is not necessarily the class that you would try to protect, but actually like just a feature of the data set that is not known to the algorithm. And we had this question that, oh, interesting, would active learning help in that regard? And so this is the basically the subject of the newly published paper that we had 3 months ago. And as you can see, like we just put some of our graphs here that using uncertainty sampling, we use BaaL, and I will explain in the next slide why we do use that. You can see that the accuracy gets higher, and also the difference between accuracy in those like subgroups of protected classes. Let's say if race is your subgroup, like the difference between accuracy of those subgroups is lower when you use uncertainty estimation. So that's like one of the side effects that I was explaining about. And if you, so what actually Fred just mentioned, it's very interesting. Of course, like active learning by itself is very beneficial, but then you have two kinds of active learning. Regular active learning uses just model confidence to select the examples. What we do is Bayesian active learning. That we believe that models, specifically like when they start getting trained over a small subset of data set, they're overconfident. So you can't really trust the model confidence to kind of like afterwards sample the next batch. So what we try to use is Bayesian active learning, which is using model uncertainty to select the next examples. Which means like we do several pass over one example, and we get the model confidence over that example, and we see like how much these different confidences are disagreeing from each other. These predictions, how much they're disagreeing. So the more they disagree, the uncertainty is higher. And interestingly, what you can see, we kind of like try to put the different examples that you can see in a data set in kind of like categorizing them based on the confidence, low confidence, high confidence, and low uncertainty, high uncertainty. What happens is that the noisy examples that we mentioned previously, they fall in the category of low confidence, however, also low uncertainty. And when you are dealing with the hard examples, either those hard examples, the model is like not certain about them, so they basically have low confidence. Some of them, they actually can be similar to other class, and the model can actually wrongly predict that example with very high confidence. So these are the subsections that you'll actually understand why Bayesian active learning works better. When you do regular active learning based on model confidence, you basically try to sample from noisy examples and the hard examples that they have higher uncertainty, but you overlook the hard examples that have high confidence. So you basically don't question them, and you kind of bring noise a lot into the attention of the labeler. But then when you use uncertainty for sampling, you focus on the hard examples. So basically the model can learn better and have a better result in performance. I think Fred is going to continue if you don't have any questions.
I think, no, I'm just thinking, like, for my own understanding, can you clarify the, so just from the regular active learning perspective, you're basically trying to pick up the items that are closest to the decision boundary. And if you compare that to Bayesian active learning, and you're saying that you're doing multiple passes, can you maybe explain a little bit how that would work?
Yeah, so the basically active learning in general tries to kind of like forces the model to choose the samples that are closer to the decision boundary. However, now the problem is like, what do you use to choose those samples? Like what kind of heuristic, right? And if you're using just model confidence, that boundary that is selected by the model based on like a subset of data is not that exact. So you're basically like overfitting to a boundary that is not properly set yet. With Bayesian active learning, you create a distribution over model confidence, and you try to see, okay, now this distribution, how much variance I have there, how much these confidences are like separated from each other. Then you're like, oh, maybe actually the boundaries that the model selected is not even right. So you kind of try to reconfigure the boundary until model starts to say that, okay, this is my boundary. It makes sense based on the data and what I've seen. And now let's just start these samples.
Yep, makes sense. Thank you.
Cool. Yeah, I might just add something on that, and I think it will help the more technical users, is that what we do is that our models are not deterministic. We have several methods in the package to do that. One is called MC dropout. And if you know dropout, you will understand it quickly, is that you keep dropout activated at test time. So when you do a prediction, it's never the same prediction that you do because the dropout mask changes. And so what we are looking for is that on a particular example with many different predictions, does it change the prediction of the model on this example? So like when Parmida was mentioning decision boundary, can we change the decision boundary such that this example goes on the other side of it? And so if it happens, that means that, okay, the model is not confident at all, even though if you just look at the confidence, it might tells you 95% confident, and you will never select that example, even though it's close to the decision boundary. And as Parmida said, in the beginning of active learning, the model is just overfitting to everything. So if you change the features a bit, like you can get huge variation in the decision boundary. So yeah.
And at that point, you're basically looking for the items that can be either on one side or another side, depending on where the decision boundary is, right?
Yeah, exactly. We're just looking for disagreement between those different prediction. Hence why BaaL is named Bayesian active learning by disagreement. So this is the heuristic that you saw. It's a heuristic that works very well on most cases.
What happens in case you have multiple, like too many items that that fit this criteria? How is there a way kind of how you can select from those items? Also, what do you want to label next? Which I think is especially important if you're trying to minimize the budget. If you have too many items that are kind of can be on the one side or another side of the boundary, how do you go further than that and select out of those items?
Right. So right now it's an open question. We are working on that though, so stay tuned for our next
That sounds
paper.
like a second webinar.
Yeah. Okay. So for now, yes, strategies such as BaaL, if you have a large amount of example with high uncertainty in the same region, is going to select out those. There are some new methods that we also have in our package. One is named batch BaaL, and this will really only select from as many diverse regions as possible. So you're not always sampling from the same space. You're like going a bit over everywhere. But this method is more expensive to run. And in production, we have this issue where like, if we're too slow on our side and the laborers are too fast, then we're not aligned. And then they are working for nothing, basically.
Yeah, and yeah, kind of one of the assumptions that I would have that you can basically take all those items, cluster them, and take the like centers of the clusters. But also the question is there, I guess, if we think about the labelers, that you would, in general, you would want your model to be able to retrain as quickly as possible, right? And then I have another question, which we may address like further down the road, is what to do if you have the models that are retrained not in minutes, but that would take days or even more than that to retrain.
Yeah, so that again is an open question, but we're also
we just keep scheduling more and more webinars.
Oh yeah. Well, we're gonna be here all year. Don't worry.
Okay.
So, but what you can do, and that we analyze multiple times, is that you don't have to use the most powerful model ever. You can use a very small model for active learning, and the labels will transfer to some extent to a bigger model that you will use in production. So
that's actually interesting insights. You're kind of using a lighter version of the model just because the retraining phase is much faster.
Yeah, exactly. And that, especially in computer vision, there's a lot of literature on that where you don't have to retrain at every sample. Like you don't have to block the labels team and say, oh, wait, I'm training. They can label a fair amount before you need to stop them. But like if it takes days to train, then we have an issue.
Right. Interesting. Okay.
Right. And this is where we do our pitch. So, so what we did is we open source a library named BaaL, which stands for Bayesian Active Learning Library. We have a very cool mascot that looks like a spider and a cat, because BaaL is a god in mythology. So
yeah, and everybody watching the webinar, I can ask you to Google the BaaL. You'll have a very interesting images.
Yeah, it can be scary. Please be advised. Yeah, and our goal was to like the methods that we mentioned, like Bayesian deep learning and dropout, BaaL. We include all of those in our library, and you can use them with very few lines of code. And so whether you want to use like deep ensembles instead of MCC dropout, you can do that. We support that. You can bring your own sauce to the mix if you want. We have a very simple API that you can implement. And recently we released the Dirichlet calibration. So we talked about calibration of the models before. We also have some utilities for that. And as you can see down below, like active learning is very dynamic. So this is the number of papers related to active learning per year. There's thousands of them. You don't have time to read them. We don't as well, but we try to select the ones that are the most interesting. So we are up to date with the latest research. As I mentioned, Batch Vault is also in our library. And also, if we try to integrate ourselves with your current pipeline. So whether you use PyTorch Lightning, Hugging Face, and now Label Studio, you can use our library super easily. And in the future, we want to support, we want to continue to support these integrations because we want everyone to use active learning, of course.
So I think what's interesting about BaaL is, and something that I was not aware when I was just originally looking at the library, that it implements multiple methods for the active learning, and you can select the one that's you think is going to be beneficial to what you're doing at the moment. And it's not just like a library that implements a single method, which I think is really cool.
Yeah, exactly. So in active learning, there's like two components. There's one that like MC dropout that will generate different predictions. And then there's a way to estimate the uncertainty of these predictions. And so those two components, they can be mix and match. And it's part of our philosophy in BaaL is that we want you to mix and match your stuff. We want you to bring your own your own version of BaaL, if you have one. Like you wake up one day and like, oh, I should try that. Like it's going to take minutes to code, and then you can quickly use it in your pipeline. And this is why we want to speed up the transition between research and production. So if one day someone releases a paper that changed the field altogether on our side or we can implement it, and we will just add it to our library, and you can use it in your active learning pipeline like the day after. And you talk about we talk about the race between us and the labeling too. So we try to provide efficient implementation when possible. So currently, I think we have the fastest MC dropout implementation. It's like very much faster than just doing a for loop. So we try to be efficient there as well. So yeah.
Frédéric, can you maybe tell us a little bit what this animation on the bottom right is about, which I think is very cool.
Yeah, so it's on this problem, it's a toy problem that we use, and I think it's explained active learning quite well, is that we took CFAR10, which is a very known data set. We only picked 3 classes, so airplane, cat, and truck. We train a model on that, and we do active learning on it. And we highlight the items that are selected by active learning. So if you would use random, you would just get a random distribution. Everywhere you would see something light. But here we see on the representation, like the items that are selected are very close to the intersection between the 3 classes. And I think this very highlight, like you don't need to care about like the items that are so far away that like they don't bring information to the models. What we want is a very clean decision boundary between all classes. And this is where your model will get good, is by selecting those items to label.
Yeah, and you can basically see that like the items that are being labeled are closer to the edges of those clusters that kind of come close to each other. Yeah. Yeah,
exactly. It's like if you have like a two distribution, if it's in the middle of the distribution, you're confident that it's going to work. And at the same time, if it's just bad data, like if you get an image that is just random pixels, then we don't need to label it as well. Like we know this will never bring any information.
Totally.
So yeah, so if you want to try our library, we have our GitHub right here and our documentation that I think is helpful, hopefully. If you have any question, you can make issues on our GitHub. We're also on Gitter, and we're super responsive.
Cool, thanks so much. I think it's been really interesting. We'll send you our swag, and we'll expect the same from you.
Yeah, you guys really should highlight your shirts before we go. I don't think people have seen them. Yeah. People are going to want this swag. There you go.
So this is super cool. This is super cool.
Even people at ServiceNow, they want this shirt, but they can't get it. It's only for selected clubs.
Can't have it, huh?
I hope we get into this selection.
Oh,
yeah, this is how secret societies begin. There's one more slide. I don't know. I actually copied your QR code to it, so we could still have that information up there if you want. If you want to go to the next slide, I believe there's one more that I added.
Okay.
Just to kind of wrap everything up with a few links. If we are at the end, are we at the end?
Yeah.
If so, yeah. So just wanted to flash this up, and then honestly, Michael, you can wrap up. It doesn't have to be me.
No, you go. You're a pro at that.
Smash that like button, subscribe. No, I'm just kidding. I'm not going to do all that. All right. Thank you guys very much for your time. This is awesome. Excellent Q&A as well, Michael. So here's some links, QR codes up there. It's a missed opportunity that it's not a spider cat. Just saying, it doesn't have to be a dinosaur. I'm just kidding. So yeah, follow us on Twitter if you'd like. You can join our Slack community here. Thank you, Frédéric, Parmida, and Michael for this excellent conversation. I hope it was beneficial for the community as well. We'll be back in 2 weeks with another webinar. So thanks, everyone.
Thanks, everybody. Thanks, Frédéric.